Okay, so this problem is, it's a fairly involved problem, but if you understand, if you break it down into small pieces, you should be able to handle it. Once again, read the problem, stop, and then see if you can do it yourself or no, and then move on. All right. So what's given is you're given a spherical balloon, a mass 100 grams. So the balloon without anything in it has a mass of 100 grams. So this is important. Okay. Now the balloon will be filled with helium of density 0.179, and such that the balloon radius becomes 15 centimeters. The question is, the balloon is suspended in air, and it's the density of air is 1.29, and we're asking if the balloon's going to float, is it going to go up, go down, or remain the same. Now, a lot of you are probably thinking at this point, hey, the density of the material of the helium is less than the density of air, so the balloon obviously has to rise. Okay. Now there is truth to that fact to some extent. Okay, and it would be the case if there was nothing else other than the helium. Okay, just keep in mind that the balloon itself is made up of some material, and that material has a mass, so we need to account for this. So even though you want to compare the densities, I think the better way to look at is you ask, okay, which force wins? Does the weight win, or the force of buoyancy wins? Okay, if the weight wins, the balloon goes down. If buoyancy wins, the balloon goes up. All right, so that's the simplest way, the most straightforward way to figuring out whether we're going to go up or no, especially when you have things made up of composite systems, like in this case the material of the balloon, which could be plastic, rubber, whatever it may be, and then the helium itself that's in the balloon. Okay, so the way we'll go about doing this problem is we'll find each of these forces, and then we'll decide whether what's going to happen. Okay, so you have your spherical balloon. Its radius is 15 centimeters. So radius is 15 centimeters, and what we'll do is we'll find the weight. We'll find the total weight pulling it down. We'll find the buoyant force, and we'll compare the two. Now, to find the weight, what we have is we have the weight of the material itself, the balloon material itself, okay, plus the weight of the helium. So we have two things to account for. Now, the mass of the balloon material is already given. It is 0.1, okay, and I multiply this by 9.8. Plus, now we have to account for the weight of the helium. Now, once again, you've been given the radius. So, to find the weight of the helium, we're simply going to do 4 divided by 3 pi times 0.15 cube, okay, which is the volume of the helium, multiplied by the density of the helium, 0.179, multiplied by 9.8. Okay. Now, let's figure out what this number ends up being. So, this ends up being 1.0048 newtons. Great. So we get the weight of the balloon. Now let's figure out the buoyant force. Okay. Now understand, the buoyancy in this problem is due to the air that surrounds the balloon. So there's all this air, and the air is what is pushing the balloon. Okay. There's no water or anything. So please don't use 1,000 for the density. We need to use the correct density, which happens to be so this is nothing but rho Vg. It'll be the density of the air, 1.29 times the volume, which is once again 4 divided by 3 pi times 0.15 cube times 9.8. Great. So let's figure this out. So this number happens to be 0.178 newtons. Okay, so clearly in this case, since the weight of the balloon is greater than the buoyant force, okay, the object is going to fall. Okay. Now we can calculate the acceleration with which it will fall, and to find that, all I'll do is simple Newtonian mechanics, W pulling it down, FB pulling it up, and then the result will be MA going down, and we can figure out A using this thing. Okay, so that's that.